Hello and welcome. I'm Aileen, Associate Director at the Ames Center, and I'm here with my colleague, Brooke. We'll let waves.
Hi, everyone. Good to see you here.
At the Ames Center, we're committed to working toward a more equitable world through math and science education. And you can learn more about our work by visiting our website at theamescenter.org. We would love to hear from you today through the chat feature. If you wouldn't mind, we started off a little chat conversation, just telling us about yourself, maybe what city or place or school you're from that you're joining us from today. And maybe even what interests you about rockets as we're going through our activity. Feel free to add comments throughout the presentation. We do look at it. We are really excited when we have that open door of communication. So today we're doing some paper rockets and we will be highlighting some practices. We always try to look at our hands-on line activity through maybe some practices or standards that are connected to school. And so today we're looking at the next generation science standards and these three practices. And what these practices are really describing is the way we will engage in this activity. So you can see asking questions, planning the investigation, carrying it out, constructing. We're going to be doing all of those things because that's what scientists, that's what engineers do. And that's what we're going to be doing today. So we really encourage you to do the activity with us as a first maybe encounter with this activity, but we hope that you'll still engage with this activity and explore later in the future. We'll also want to think about the STEM that we're doing today: science, technology, engineering, and math, and where we see those things. Now, rocket science has a lot of these things in it. And I'm curious today what you might think is the most important thing in rocket science. Do you think the science part is the most important, the technology, the engineering, the mathematics? So if you'd like to respond on what you think is the most important thing, I'd love to hear what you think about that, where you think the STEM is, or what is the most important piece in rocket science, because it's a really interesting area of study. And while you're doing that, we want to share some rocket facts with you. And Brooke has some ideas and some facts that she wants to share before we start engaging in our activity.
Okay, so this first picture that you're looking at is kind of helping us get an idea for how large these rockets are. If you look at the one furthest to the right, that's Saturn V. And it's currently the tallest and most powerful rocket that we have to date. So it's also the only one to carry humans beyond Earth's orbit, which is pretty cool. And this one is the one that sent astronauts to the moon on Apollo 11, 12, 14, 15, 16, and 17. So it's towering at 111 meters, which to put in perspective for us is 336 feet, or about the size of a 36-story building. So that's Saturn V. And then if you look in the middle, the kind of white and gray ones towards the middle, those are SpaceX rockets that we've been kind of hearing a lot about.
Yeah, so private companies like SpaceX have been arising and creating their own rockets to go to space. So we're usually, in the history of our rocket science, are usually through NASA, right? We hear about NASA and how NASA is creating this space exploration space. But now we have some private companies. We have SpaceX, Blue Origin, the Virgin Galactic. So can you tell us a little bit more about what SpaceX has recently done?
Yeah, so what you're going to be looking at is, this is the Falcon Heavy. SpaceX also has the Falcon 9. And their hope is to eventually go to Mars with these rockets of theirs. So currently, this Falcon Heavy that you're looking at here is traveling to the International Space Station, and it can lift 141,000 pounds of cargo, which is 2 times the weight of the shuttle. So pretty powerful, pretty amazing. It is 230 feet tall, and it uses 27 engines just on the first stage at liftoff. So thinking about the kind of power that creates, at liftoff, it is 5 million pounds of thrust. And to help us think about that a little bit, that's the same as 18 747 planes. So a lot of power there.
Yeah, definitely. And for those of us who've been on an airplane, we know the power of that liftoff event when we're on an airplane. The International Space Station, you mentioned that. I mean, wasn't there some current news about the International Space Station and things that are happening right now?
Yeah, so International Space Station just celebrated 20-year anniversary, which is great. But that actually marks 2 decades of humans habitating space continuously. So we've been in space for 2 decades without ever leaving. So that's pretty cool. But this other really great thing happened just in October. On October 16th, you may have heard there was the first all-female spacewalk. And the astronauts were Christina Cook and Jessica Meyer. And they were tasked with replacing a power controller on the ISS. And so you might think like NASA planned this and they were, creating the first all-women spacewalk. But what NASA said is that there's been such an increase in the number of women that are becoming astronauts that it just naturally occurred. So that's pretty cool too.
That is so cool because we know that as inclusion and diversity happens, we can see other people exploring and really to know that all students have that new dream and ambition that they could be an astronaut in space and maybe be one of the first ones to go to Mars. That's
Yeah,
amazing.
for sure.
Has there been anything else with rockets that has occurred recently? Maybe we could just go over, and I think it's exciting to think about all the things that are happening right now.
So there's 2 more space probes that had some recent news that I wanted to tell you about. The first one is the Voyager 2. There's some information you can check out on the screen, but just to give you a rundown, it was launched in 1977. So that was 43 years ago. And currently it's 11.6 billion miles away. So it's far. But the really cool thing is it just recently sent us a hello. So thinking about the kind of computer memory they have on the Voyager 2, the iPhone 5 actually has 240,000 times the memory of the Voyager 2 spacecraft. So that's how they got the hello to us.
That's amazing to be so far away and be able to still communicate with it.
Yeah. So there's one more space probe as well, which is the OSIRIS-REx. Just about a couple weeks ago was in the news as well. It touched down on an asteroid and it is 207 million miles away. So also, I mean, that's far enough. But be looking in the future for news of that spacecraft bringing back some material from this asteroid that it touched down on. And then one more cool little tidbit, it actually took 18.5 minutes for the signal to reach us from that 270 million miles away.
That is amazing. And we have some responses to our question about maybe what's the most important STEM piece in rocket science. A lot of people are saying all of them are important, which I kind of agree. They all are really important. But as we're talking, we're highlighting the engineering because we looked at that picture with how we're evolving in our rocket science ability and just creating the rockets. Mathematics, definitely important. You definitely want to make sure that all your calculations are accurate, precise. I mean, if you have seen the movie Hidden Figures, when they were talking about the trajectory and being able to come back to Earth and how precise that had to be. I mean, I think that really opened my mind to the importance of mathematics in these areas as well. So yeah, I think all those pieces are really important, and it really does take collaboration to make it happen. And not just one engineer, but a group of engineers, a group of mathematicians, a group of scientists. And so all of those pieces are really important. So we're really, go ahead. Sorry.
I'll even give a shout out to art, which sometimes we throw art in there. If we looked at those rockets in that picture, they were all beautiful as well. So design pieces also in there too.
Definitely. I remember I think it's the Saturn V that there's a Lego construction piece out of that. So that would take some engineering just to put that together, I can imagine. So we're going to make paper rockets today. So Brooke, can you take us through an introduction and we'll kind of get started to get into our activity?
Absolutely. So some of the concepts that we're going to try to just think about as you're creating your rocket, as you're playing with your rocket, we're going to have a little bit of time just to play with our rockets, have some fun with that. Just kind of keep in mind the concepts of drag, lift, weight, and thrust. Think about the different variables that play a part and affect your rocket, how it flies, the weight of the rocket. Even when you're constructing the rocket, keep in mind and come up with ideas of how could you change your rocket along the way. If you wanted to make another round, what would you want to change or try differently? And think about these particular concepts and how your changes or the way that you play with your rocket might affect those.
Yeah, and I really love this diagram because sometimes jokingly we call complicated things rocket science, right? But when we really think about it, if we go down to the components of what this is something that we can all engage in. I love this activity we're going to do today because it really can engage little ones as well as adults in thinking about these components and what your goals are and how you adjust to meet those goals.
Definitely. Definitely things to keep in mind, even thinking about what you would be asking kids as you were playing and engaging with these rockets with them. So the next thing we're going to do is get into actually making our rockets. So we'll do a double check real quick on the materials you need to have available. Pretty simple: paper, scissors, glue, 2 pens or pencils with slightly different diameters. That's just because we want one of the tubes that we're going to make to be a little bit thinner in diameter than the other. But if you didn't have 2 pens that were different sizes, that's fine too. You can just kind of eyeball it.
Yeah, definitely. And so while Brooke is setting up her camera, I just want to let you know that, the paper is really an open-ended thing. So if you want colored paper like Brooke is showing or copy paper, you could also go to your recycle bin and get some newspaper or maybe the grocery advertisements. I mean, we want to engage in ways that we have things around the house as well, and not necessarily always think about, I need to have this specific item, but really explore and engage with different types of weight of paper. And that could be like your newspaper or other paper that maybe is in your recycle bin. You can even think about, you have a grocery bag, a paper grocery bag, you can get some paper from there. The glue, you can have any adhesive if you have some tape around, or any kind of tape would work. So don't try to just think about the things specifically that you need, but try to think about other things you can explore with. Maybe even unintentionally, we use other things that are around our house to substitute, and it turns out better, or we discover a phenomenon that we didn't know existed. So lots of ways to explore this. So if you're gathering your materials, think about other things that you might use as adhesives or paper. All right, so I'm going to turn it over to Brooke. She's going to be showing us in detail how to put together our paper rockets. I will be watching the chat. So if you miss anything or have a question, go ahead and put in the chat and I'll share that with Brooke. So I'll hand it over to Brooke now.
Okay, great. So you can see I've got a lot of different materials here just to give you kind of an idea of what we're making. We're going to have a rocket and we're going to have the launcher. So as Aileen was mentioning, there are different ways that you can go about this. And if we have any preschool teachers in the house, go ahead and give us a shout out on the chat. One idea for you guys: if it gets too challenging for the students to make a smaller launcher, a straw is another option, and that'll fit inside and works just as great. So again, like Aileen was saying, you don't have to be super particular about your materials. You can be kind of creative, change things up a bit. So to get started, we're going to make the launcher. And so I've got this paper here, and I pulled out a pen that is my smaller diameter. So this first one is going to be the launcher. It has to fit inside of the rocket. So we want this to be our thinner tube that we're making. So I'm going to kind of start rolling this One thing that can happen is your pen can get stuck in your rolling. So I'm going to try not to let that happen. If I do, oh well. Okay, so I'm going to start gluing just because I want it to start kind of sticking as I go. And then I'm just going to keep kind of pulling my pen out. But however you get this rolled up, whether you use a pen to help or not, the whole point is just that it ends up being thinner than the second one. Okay, so for this last part, I want to make sure I get this glued down. And don't worry if you don't have colored paper. You can use white paper, which can even be a lot of fun. You can start to color and design on that paper. Okay, so I'm going to go ahead and just kind of cut the tips off so that kind of looks like this when I'm done. All right, so we've got our launcher ready. And I decided to use another color to make the rocket body. And the first thing I'm going to do is just cut it in half. So we want it to be shorter. As you can see in this one, it's about a little less than half the size of the launcher. So just go ahead and cut it in half. Again, nothing has to be precise, and keeping in mind as you're building, feel free to come up with different ideas of how you might want to modify or change your design. And as I'm building the rocket body, I just want to make sure that this is going to fit inside. So I'm going to slightly use a pen, but kind of just leave some extra space in there and give it a little glue to hold it together. Okay, and glue this. Okay, so we've got our rocket body ready to go. Okay, so all that we really have left to make is the cone and then the fins. So you can use the same other half paper that you just cut off to make the fins in the cone, or if you want it to be a different color like I do, I'm going to just cut another piece of paper in half of a different color.
I was noticing, Brooke, as you're rolling that, as we think, I know we had some early ed teachers give a shout out, that these are some of those motor skills that young children are developing, like when they play with Play-Doh or do things like that, where they're rolling thing and doing that movement is a way for them to kind of practice that. And they might need some adult supervision, like putting the glue there in the right places, but those motor skills are also being developed at that same time.
Absolutely. There's all sorts of ways that we're supporting our kiddos as they're growing and developing and just engaging with them. And okay, so next I'm going to make the fins next. So it doesn't matter what order you go in, but I'm basically just going to cut maybe like a third of the paper. Not super important how big it is. All right, so when you fold this, you're going to fold it in half once and then in half again. Okay, so that second fold, this is the side that you're going to want to draw from. So I'm going to turn it this way. So I've got the first fold at the top and I've got the second fold over here. And I'm just going to kind of draw what I want my rocket fins to look like. So I'm going to just do something like this. So maybe this is part that you could explore with. Try different fins. All right, then we're going to cut just along our drawing there. And we should, if I did this the way I wanted to, I should have two fins. And there we go. Okay. So I want to put these onto the rocket body. And so I want kind of like a flat space in the middle. It's not super important that you do this, but I'm going to kind of fold this in and fold this part in here. And that just kind of gives me this space on the back to glue on. And from there, we just start gluing our rocket together. Okay. Okay. Feel free to share in the chat if, as you're building this, you're coming up with any ideas, or if you're having to make some adjustments because of the materials you have, or maybe didn't have. Anything you'd like to share with us as you're building. Okay, got this other one, I've done the same. I'm gonna go to the opposite side of the rocket body and add that there. Okay, we're almost there. Okay, so the next part we need is, of course, the cone. And so I am going to use this. You don't have to have anything circular. Most of the times that I've been making it, I've just been kind of eyeballing a half circle. But we basically want around a quarter of a circle. It could be a little larger than that. But I'm going to use this and just kind of have it help me draw about a half circle. You could always use a compass. You could, like I said, just eyeball it. No big deal. Okay, so again, we're making a half circle just so that we can make around a quarter circle. Okay, so that's probably about a quarter circle. I'm gonna make it a tiny bit larger just because I found that it was easier for me to glue it together.
So we have a little request to go a little slower and give our makers a little more time.
Okay.
So maybe it was the fins that people are kind of.
I'll go back and do the fins again because that one can be a little different. One thing to keep in mind, I have some fins already made. There's no rules in how you make it. So we need two that look kind of like this, just so that we can glue it on and end up with 4 fins. So this is the shape I end up with. And if you kind of look, there was the fold that I started on here. So let me start again, and you can kind of have this just so you can kind of see what shape that is. And I'm going to go ahead and cut. I started out with a half a sheet, and then this took maybe about a third-ish.
And this is where they can explore. So how big your fin is, what shape it is.
Absolutely.
So many different ways. There's not a right or wrong way. And I think that that's what makes it fun.
For sure, getting to explore different shapes. And then especially after you launch your rocket, you can see, does it change the way the rocket flies? What happens? So if you notice, I just took that about a third of a half a sheet. Somebody do the math. How much is that of the whole sheet? All right, fold it in half here. And then I'm going to fold it in half again. Okay, so if you notice, after the first fold in half, I folded in the opposite direction in half. And this is the part that I'm going to have be this. So if I take that, I'm kind of just using that to make my fin. So I've got this folded part at the bottom. I want to make sure I cut all that off, or I can put the fold at the top and then I don't have to worry about it.
It sort of reminds me like our snowflakes that we make during this, Christmas time and the holidays, where we're trying to draw what we want to see what the end result will be as we open that up. So even that exploration is kind of interesting, of what you're drawing and then opening that up.
Right. What do you think it's going to look like? Of course, we already know, but it's a good question as we're building. So that's kind of the shape. And again, I've got this folded piece at the top, and I've created that on this folded part. So hopefully that helps. And then we're just going to cut that out. Okay, and I ended up with something like this. And again, these are this one's pretty different than the first one, so it doesn't have to be exact. So those are our fins. And as far as the folding, if you missed that part, all I did was fold in from the side there and in from the side there. And that just gave me a flat base for gluing. So that's kind of what we end up with. And we glue 2 of those onto our rocket, and we've got our 4 fins. Okay, as far as the circle, so my goal in the end was to get about a quarter of a circle. Like I said, I made mine a little bit bigger than a quarter of a circle. And I cut that out after using this little guy. And again, you don't have to have this. You can be more precise and use a compass. You can do whatever you'd like. Or we can just eyeball it.
So it's a lot of shapes. I mean, someone mentioned in the chat how the fins look like half of a trapezoid.
Yeah.
Now we're using half of a circle.
Now we're using half of a circle. There's so many different shapes, cones, and as you were mentioning, trapezoids and circles and half circles, and so many opportunities for mathematics and geometry. Okay, so after I made a half circle, so I've got my half circle. That's how I got my around about quarter circle. So like I said, I went a little bit bigger than a quarter of a circle, just a little bit, just to give me more gluing space. And so we've got our circle, or our quarter circle, and that's what we're going to make our cone with. So you can use the tip of a pen if you'd like to help you kind of make your cone. So I'm just kind of wrapping it around and kind of getting the shape ready, and then I'll put some glue on so that it'll stay that way. Okay, so I've kind of got the shape, and I've got my glue. You might want to use one of your larger pens to shape it around, since it's going to fit around this. We are going to make some cuts in here so we can squeeze it together so it'll fit better. But okay, so I'm going to glue this together and get our cone. Okay, so if you've got your cone, you can kind of set it aside, let it dry a little bit, and we're going to get our rocket base. And on the opposite side where the cone is going to go, we're just going to make some slits in the end so we can kind of scrunch it together, put some glue around it, and then we'll put the cone on top of there.
Brooke, we have a request to show one more time how you form that cone over the pencil. Would you show that one more time, maybe with another? Yep. Yeah, that'd be great.
Okay, so here's my little bit more than a quarter circle. I just got the tip of a pen. I would have used this one that I actually formed the base of the body of the rocket with, but it doesn't quite have a pointy tip. So you basically, the only reason you need a pen is just to help you kind of create that cone shape. So the tip of the pen's going inside, and I'm kind of just wrapping. I didn't put any glue on yet because I found that if you almost kind of mold it a little bit first, that it's helpful before you put the glue on. So just kind of molded that around there to get my cone. And one time when I was trying to make one, I ended up making the initial circle just way too small. And so my cone wasn't large enough, and then I had to start all over, which is great because you're kind of exploring and trying new things. So if you need to, start with a bigger half circle if you're finding that your cone is too small. Okay, so now that it's kind of formed, it makes it a little easier just to get that cone formed.
And I think this highlights what's different than just cutting some pieces out of a template.
Yeah, for sure.
The opportunity to explore and design and go back and fix maybe something that of your design that you can improve is made possible if we just don't, follow a template straight and cut those pieces out. We have more of this leverage of autonomy, but also creativity.
Yeah, definitely. And it gives us, again, the opportunity to talk about all the different shapes, all of the fractions and numbers and things. So,
and then we have rockets, like someone said right now. We have rockets that all look differently, but that's the power of seeing everybody's design.
yeah, for sure. So feel free to explore, feel free to put your own imagination into it. And but again, if you need me to slow down on anything else, I appreciate you guys letting me know so that I can make sure that you all can follow along and make your rocket how you want to make it.
Yeah, so I think we're ready. I think we're ready to put the cone on.
Okay, so I took the rocket body and I'm making slits. I've made a couple already, but I'm going to go actually all around, and I'm going to just make some slits.
So those about what, a half an inch around?
Around there, yeah.
Okay.
All we're wanting is that when we're done, we want to be able to squish this together. So that just kind of helps us squish.
Okay.
Because we want the top to be thinner so that we can get that this on there. So as I'm doing this, I'm noticing I kind of want mine to be a little further, so it might go together a little better. So I'm gonna just make my slits a little deeper into the rocket.
Okay.
So how's it coming along? Are you guys making some cool rockets? Anyone try anything different or find something that helped them? Okay, so I made them a little longer and it's kind of squishing a little bit better together. So now I'm just going to put a bunch of glue.
So we have some people are using tape instead of the glue.
Nice.
So that's going to be an interesting. And since, we're using our launchers to blow into, it may be interesting to see how the tape maybe covers the air passage there to make maybe more pressure than you might get if you use glue. It just depends on how the design is.
Absolutely. Okay, so let's see if my little rocket holds together. Yep. That's why I kind of wanted this cone to have a minute to set. Oh, nope. That's what I mean. So after you get this on there, perfect. See, I needed to make two. Okay, so we've got our cone on. And now I have a cool rocket.
Very cool.
And then you have your launcher from before. And hopefully it fits in there. Another thing that I can try is a straw. That'll work as well. And we can just give it a second to dry. So how's your rocket coming out? Did your rocket come out good?
We have some people using newspaper print.
Oh,
so
cool.
That's going to be an interesting piece there. People are saying their rocks are sturdy, trying to make it very sturdy. So maybe if you're using cardstock, you'd get it a lot more firmer, but that would add weight to it. So I wonder how that would affect the flight.
Definitely the materials we're using can make a big difference. gonna get some of this stuff out of the way.
Using notebook paper and glue. Someone's using notebook paper. That's a little thinner than copy paper, so that's going to be interesting.
And feel free to share your pictures with us. I know we had shared in the beginning different social media tags and things that you can share how it's going, even if you want to take videos.
All right, so I think Brooke is going to show us the launch, maybe?
Yeah.
Great.
Okay.
Going to demo how we launch, and we'll give about 5 minutes after you're done with some playtime.
Sounds good. Okay, I'm just gonna turn my camera a little bit so maybe we can see farther where it flies. Okay.
Cool.
Did you see it?
Yeah.
Okay, and then just for fun, I'll use the straw also just so we can see it really does work too.
Yeah. Definitely. A smoothie straw too. You know, they have those smoothie straws that are a little thicker.
Oh yeah, definitely. It gives us reasons not to throw them away.
All right, so we're going to encourage everyone to take a little time to play. We're going to give about 5 minutes, and we really want to think about what you're noticing as you play with your rocket. Maybe you have some more specific questions, what you're wondering about it, maybe what you're curious about it, just like the screen says, and interact with us. If you take any pictures or short videos, make sure to tag us on social media. We'd love to see them or see them afterwards. So we're going to give about 5 minutes and we'll see you very soon. Enjoy playing.
Have fun.
back, everyone. Thank you for sharing in the chat. It's been great to see some of your exploration, some of the things that you're trying and discovering and what you're curious about. We also like to take this time not only to play, but also to debrief a little, because we know that we have a lot of teachers and also parents with us today. And we really believe that it's not only about doing the activity, but about reflecting on the activity and how we engage with children, because children do need adults to help them in their STEM education or their STEM learning. So, Brooke, I wanted to ask you, and maybe you can highlight some of the questions a parent or teacher might ask, and how do we support our children or our students in engaging in this activity?
Yeah, great. So just some of those words that we had on the slide while we were playing, just what are you noticing? What do you wonder? Or what are you curious about? And just asking some of those simple questions can get them to think a little deeper about what they're doing, maybe what's going on. But some other ones might be, what makes the rocket go forward? So what is it that's causing that to happen? Or what's keeping it from not going forward forever? And feel free to throw in questions that you thought of, that you're thinking as you're processing, how would I engage with my students or my kids with this? What are some questions that you might ask? And just some other ones, how far will it go? Get some mathematics and measurement in there. And then thinking about the angle of the rocket, how can we change the angle? Or what would happen if we changed the angle? And anything else, just what do they want to change? What do they want to try?
Yeah, definitely. And encourage them to make a goal. I like what you said about how far, because how can we make this rocket go farther would be a great, so the kid might think, your child might think, oh, I need to blow harder. Well, yeah, that's one way, but is there another way that we can make it go farther? And maybe consider your weight or your fins or even the placement of them. I mean, there's so many other things to explore that we really want to encourage a child's curiosity, because that's really a vital gift for learning.
Absolutely. One of the suggestions we have from the chat is have a target for them to hit, which is always going to be a ton of fun. And you could kind of mix that with what you were suggesting. So if we want to hit this, but we can't get our rocket to hit this other target that's further out, what could we possibly do to see if we can make a rocket that can hit that one? We also, go ahead.
I was just going to say, we have a lot of early childhood people with us. So as you're thinking about this, I mean, exploring further is not only some of the rocket information we shared today, but also, you might think of a book that you might share that talks about an astronaut or talks about space, and then really evolve this activity for them to not only build their own rocket, but to also read about it. And you might find them reflecting on the activity through a book or a story or some art project.
Definitely. We have a couple more suggestions, asking how high they can make it go. I mean, that could get into things about the angle that they shoot it at, or they blow from, or the design. All sorts of things could come from that question. Also, stomp rockets might be nice for pre-K. So there are stomp rockets. Well, I believe we actually have something to share with you afterwards. If you've joined our list, then we can share that with you, where you can actually make one of those stomp rockets. It'll take a little bit more materials and things that you might have to go to your hardware store to get. But if you have another idea for stomp rockets that uses some more common materials, let us share with us.
Yeah, and it's really great to explore different ways to make it go. The energy or the power that you need to make a rocket go, whether that energy comes from yourself or from stomping on something or some other way. Throwing a paper airplane is a way to make it launch. I mean, there's so many ways to think about how we have that energy behind it or that power to make things go.
Definitely will make those images we saw in the beginning a lot more interesting as they start to think about what's actually happening when they look at real rockets and see things like the space probes and the rockets from SpaceX and from NASA in the news.
We have sharing some of the things that we did to improve our rockets. So I think that, sometimes with especially younger children, if something doesn't work, we see, them getting upset or them trying, maybe giving up, but really encouraging that perseverance and understanding that we learn by that the iterations, the times that we make something and then we redesign it. That is actually what real engineers do. They make these prototypes and then they improve on them. So really getting children into the habit of creating something and not going to, quitting right away, but thinking, how can I improve this? Because the joy that we know as adults we feel when we use tape or solve it some other way and then we see it be successful is what we want children to discover, that piece of perseverance and then seeing that joy on the other end when you have some success is what we want to encourage them to keep going and keep doing.
Definitely. All of those different variables that we explored and played around with, people use tape rather than glue, the design, the way it's shaped, all of those things are things that real uh, rocket makers have to think about. And so in a more simplistic form, they start to form these ideas around what's important as you're thinking about creating something. And yeah, so it's definitely a fun thing to do with kids. And who doesn't love rockets and love playing with rockets?
We have another suggestion about counting the steps. So getting children to count is really important. I mean, when you're counting, not just to count, but counting toward a goal. This is a great goal. See how far my rocket went by counting the steps of how far it went is a great thing to think about it. And there's so much math that we encountered throughout making this. I was thinking about the very simple like cylinder. We're making that cylinder and that's the body of our rocket. And then we have our cone shape, right? And these are the shapes that children are learning in very abstract, simple form. But how much more is it powerful for them to see that and how those come together to build a rocket? And what's great is that this is play based. I mean, they're creating and they're playing with the rocket, they're seeing it go, but all of the STEM that's really surrounding this activity and the conversations that can happen and using those words. I mean, Brooke, you used so many math words as you were going, like we're gonna change the semicircle into a cone. I mean, all of those, we want children to engage with academic vocabulary, not memorizing it on a flashcard, but actually using it as they're doing that. And I think that that's powerful, a powerful example.
Definitely giving an opportunity to learn in context and while they're having fun.
Yes, so we wanted to share some resources and let you know that there is a one pager on this activity, as well as we will post the recording of our hands-on line, but there is a one pager that will have a synopsis of this activity, of the materials you need, a written out form of Brooke's explanation of how to put that together, and free to use to share with others, let them know that you attended the hands-on line and encourage them to attend our next one, but also some extra resources, because part of this is just giving you a taste of this exploration and there's so many other things to discover. That's one of the most rewarding pieces about being a teacher, is opening that door for students and letting them go through it and seeing how far they go and how they just love learning and love exploring. You'll also find one pagers for our past hands-on line if you didn't join us, other ways that you can engage with STEM through playful activities like this. And so we encourage you to visit our website once again. Brooke, was there any other thing that you wanted to, just remind everyone about, or things to explore or encourage?
No, just thank everybody for coming. I had a blast. I hope you did as well. And hopefully we'll see you again in the future.
Yeah, definitely. So once again, on our website, aimcenter.org, you'll find all the resources. And we do want to remind you that we have another Hands Online webinar coming up December 8th, 3:30 to 4:30, same time. And we're going to be doing a slow marble roll. All these hands-on line activities are what we hope can engage you with very common things that we'll find around the house, but ways to just exhibit curiosity, intrigue, wonder. And so really to try to be inclusive and try to invite everyone to do STEM together. So we're really thankful that you joined us today. Thank you for being engaged with us, for letting us communicate with you today. We hope you'll share your pictures or short videos. And even in the future, maybe as you do this in a classroom throughout the week or next week, please share with us. We'd love to see how people are using this. And we thank you for inviting us today into your world of STEM. Brooke, thank you so much for bringing this activity with us, for sharing with us. I know you did a lot of work in research and exploring yourself and being a scientist and engineer and going into rocket science. So I really want to thank you for that.
Thank you. It was fun. Had a good time.
So once again, thank you on behalf of the Ames Center, and we encourage you to keep exploring, and please visit our website for more resources and more ways that we can be partners in STEM education. Have a great day, everyone.